My name is Eric Stamber. I'm going to be giving today's presentation and demonstration. Today we're going to be covering getting started with ANSYS SpaceClaim. So just a few quick introductory slides before we jump into SpaceClaim. So CAE Associates, we're an engineering consulting firm in Middlebury, Connecticut. We specialize in FEA and CFD analysis. We've also been an ANSYS channel partner since 1981, so we provide ANSYS sales, training, and technical support. And this e-learning, it's part of many in a series. So if you would like, you can view previous recordings either on our webpage or on our YouTube channel. There's already a few up there related to SpaceClaim. So those are building flow domains, removing geometry bottlenecks, and basically an intro SpaceClaim video as well. So those are available for you to check out. You can also look at our resource library on our webpage. Something new that we have up there is the version 17 update seminar notes. And there's a bunch of models and scripts and macros and case studies and things like that on there as well. So if you'd like, you can always check that out. We also have a blog that is updated weekly. So if you're not a subscriber, you can sign up to it, and then you'll just get an email once a week with whatever that engineering topic is. Usually it's an engineering topic related to FEA or CFD. And we also offer training in our office in Middlebury. We can do the training on site at your location and also online. We have, related to SpaceClaim, a one-day class that's offered in our Middlebury office. So if you're interested in it, you can look it up on our webpage and sign up. And if you are a New York or New Jersey resident, you can earn a continuing education credit for attending this full webinar. You just have to complete the polls and then the survey that will be sent out to you at the end of the presentation. So then what we have in store for us today, getting started with ANSYS SpaceClaim. And there's a lot of features to SpaceClaim. It's a newer 3D modeling tool. But today we're really going to focus on using this tool to prepare your geometry for an analysis. So, and then in terms of the basics, related to that, we're just going to do just some understanding some basic SpaceClaim usage, and then we'll just build a model from scratch, just showing how to do that. And then some of the things that I use SpaceClaim for a lot, which is interrogating models, looking for gaps and interferences and things like that in assemblies. And then we'll clean up some CAD geometry at the end, doing a little defeaturing. So with that, we'll go into SpaceClaim. But before I open up SpaceClaim, Christina, if we can take our first poll, just find out in the audience how many people are currently using SpaceClaim. So you should see a poll pop up. If you could just provide an answer to that, and just so we can see if anyone online has been using SpaceClaim. I'll just give you a little bit more time here to submit your answers. Okay, and so then the results of that, let me just drag over these bars here. So you're currently using SpaceClaim. 7% said yes, 80% said no, basically. So that's good. Either you haven't seen or haven't used it, so this hopefully will be useful to you to get a little bit of an overview of SpaceClaim. So this is what it looks like when you open it up. If you don't have a model loaded in, you have basically nothing in the structure tree at the moment, but you have a bunch of tabs up on the top here which contain a ribbon of icons. So to start off with, we're going to be in sketching mode, which is the mode that it puts you in when you open the software. There's also two other modes. There's in addition to that, it's a cross-section mode, and then there's a 3D modeling mode. So these are the three modes of SpaceClaim that we'll use in this first demonstration. So in the sketch mode, we're going to use some of the sketching features in here. But instead of just drawing apart from scratch, I'm going to drag over a picture and just place that onto our sketch plane and orient the view normal. I've used this actually quite a few times, surprisingly, to help guide the model that I'm building. So there's also, I should maybe mention this quick, is that under Insert tab, there's a reverse engineering section. There's a feature here to vectorize image. So I could actually convert this image to a bunch of lines directly with this tool, but this image is pretty poor quality, so it doesn't do a good job of that. So that's something that's there. But we'll create basically just a simple reactor vessel. So to do that, I'm going to just sketch the inside profile of this vessel. I will then take that profile and revolve it around the center line to take that edge and create a surface. And then once we have a surface of this, we'll extrude the surface into a volume to give us this whole profile. So that's the high-level approach that I'm going to take to making this geometry. So I'll start off with under the sketch tools here, just left-click and then grab a line. So I'm just going to left-click once to start a line, left-click again to end the line to put a center line down the part. And just roughly sketching this. You probably want to scale everything to be the right size initially too, but you could also do it at the very end. That way the size of this actually corresponds to the dimensions in the picture. But if I go through here and just create the inside profile of this edge with another straight line, and then hit the escape key, will get me out of creating that line. And then maybe just create a couple straight lines here for this top flange. So just creating some geometry to work with. Now this profile that is going to curve through here is going to kind of eyeball it with a spline. So there's a spline feature. If you move the mouse close to the endpoint, then it can snap to the edge of this line. If I hold the Alt key on the keyboard, then it will put a couple parallel lines to make this tangent. So now I'll click that, and this spline will come off tangent. And I just want to kind of get this edge through here to match up. So maybe somewhere about there gives it kind of close to matching up. Maybe click here and click here. Once I'm done with this, then I can just hit the escape key to complete that operation. And if I wanted to, I suppose I could, maybe try to use the spline and just make a tangent to both ends holding the Alt key. So that lines up over there, and then let's just put in a couple quick edges down here just to complete this sketch. And this time, maybe I won't put that radius in, so we'll just grab a tangent location with the Alt key, click a couple points here, and close out that line chain. So now we have the inside profile of that vessel. If we go into the 3D mode, right here with this button, and now in our structure tree we have some curves and we have the sketch. If you want to hide the sketch, I just have to uncheck that checkbox. That's how you turn things on and off. So I have this profile that I want to revolve around this edge right here. So how do I do that? Well, most of the things in SpaceClaim can actually be done with either the pull, move, fill, or combine tool. And notice those are pretty big icons compared to everything else, so those get used quite frequently. So there's a lot of operations that can be done just depending on how you use these features. So one of which is pull. If I click on that, if I actually hover over this icon for a second, come on, you should see that it says pull. So select faces to offset, revolve, sweep. Also press F1, and then it will bring up the help on this feature. So you can always, jump right to the help section and read up on what this does and how to use it. So one of which is to select or drag edges or faces. So if I triple click on this edge, it gets all of the lines, and then we see the little arrow for the pull direction. So with the left mouse button, if I click anywhere in the model, it doesn't need to be on that arrow, and then just drag forward or back, you can see this is the direct modeling where it just kind of gives you feedback instantly on the design change. But right now it's pulling straight in a particular direction, which is not what we want. So let me just undo that operation. We want to revolve the sketch, so about an axis, which is our center line. And then we want to go 360 degrees, so I could either left-click and drag it all the way around, or just click this button, which will do the full pull and revolve it around 360 degrees. So that's revolving. If I, let's say, go down here, because I didn't put that I didn't put the edge or that blend in down at this location. If I turn the tank back on, we can pull an edge. So I'll just left click and just hold and drag and see that it it drags it to a set radius that I pulled it up to. I can use the space bar, and then it will free up the number that's in there, and I can type in a value that I want that to be. And you see that I'm just grabbed that edge and pulled it into a radius. So it tries to be smart based on what you have selected and what what you're doing with the pull. So now, if we just create a little bit more of this geometry, this inlet that's up here. So if we go into the sketch mode to make that, I'll turn the image back on, go into the sketch up here, and it wants to know where that sketch is going to be located, so I could put it in different locations on the geometry. I'm going to click the picture, that way back in the sketch mode parallel to that image. And we'll create this port. So we can do that again just by creating a simple line. That line goes down the center line of this port, and it kind of snaps to 60 degrees. You can use the tab key, and then that will toggle between these different measurements. You can type in the values you want. So you can edit all this stuff, make changes anytime. So I'm just going to grab this top little lip right here and go back into the 3D modeling mode now, and then we'll do the same exact thing that we just did. We'll grab, with the pull tool, this edge, revolve it around this axis, 360 degrees with this button. Now, if I grab this inside edge right here, and I'm still in the pull tool, see this yellow arrow is brighter than this dark one. So that's the pull direction out of the two. You can also use tab to toggle between the two. But if I just, with the left mouse button, you can just drag and resize this to a different size. I'm just going to Control Z to undo. So that's not the direction I want this to go. I want this edge to pull down into this vessel. So I'm going to set the pull direction with this little arrow icon to set the pull direction to be parallel to this center line. And I want to pull this edge up to, with this option right here, to the surface. So now it extruded that edge all the way up to this surface. And we see what we have now in the outline tree is two surfaces, one surface right here, another surface with this top port. So we don't have a hole in this vessel right now. So let's create that. We can do that with simply splitting the bodies. And splitting is done with the combine option, which this is really Boolean. It's split or merge, even though the wording may be a little misleading, let's say. So combine, I will click the body that I want to split, click the body that I'm going to split with, and then the third click with the left mouse is if you hover over the intersection, you can then click and remove the body that was in red. So now I have two bodies, but they're cut out. Now, still with the combine tool, we might want to add these two surfaces together. So I'm going to click this body to start. I can hold the Control key, which will toggle these back and forth, or you can just go and then click this icon. So now, click this body, and then those two surfaces got added together. So we can either add or split with combine. So that's good. Now we have, let's just say we're good enough with creating our surface. It's pretty close to the tank geometry here, minus some other ports. Let's turn this into a solid. So we can do that, again, with the pull feature. And this time I'm going to select, in the outline tree, this entire body, this surface body. So with the pull feature, if I click on the left mouse, just click, and then I'm going to drag it a little bit, and it will pull that surface into a solid. And then with all the surfaces selected, it all gets extruded in the normal direction. I can hit the spacebar key to free up the number that's in there, and maybe we set this to 0.3. Again, we probably want to scale this so that it's appropriately sized based on the picture. But now we have a 3D solid of this vessel. So the last mode of SpaceClaim that I haven't talked about is this cross-section mode, which we might want to use because now it's hard to see the inside of this vessel and our picture that's in here we're using to draw things. So let's let's just click the section mode, and it wants to know where this section is going to be placed. So I'm going to click the image again, just so it's parallel to everything that we've been doing so far with the image and sketch plane. So we are in a section mode, but we're seeing the 3D geometry, so we see that overlaid on our picture. If we didn't really draw it that accurately, we could certainly make any changes at any time. That's kind of the direct modeling approach, is that if you want to move this diameter, just use pull, and then just drag it to the size that you want. So, maybe I want to set it to a radius of, let's say, 2, so then it's a proper size. Maybe this flange needs to go up a little bit. We could drag that. If you grab vertex, when you pull that, it's creating a round. And again, remember, this is just a cross-section. Everything is happening in 3D. So we're editing it, on the section, but we're really creating a 3D change. So we could see that if we go back into the 3D mode. See we're operating in 3D on this. So that's I think enough with creating geometry from scratch. But you see, it didn't take us very long to create this. It's pretty easy to use with a very few number of clicks and operations. Something else that we might want to use SpaceClaim for, at least in the very beginning, if you've never used it before, is drag over an assembly. And I use this all the time when, basically whenever I start a new project and need to look at the solid geometry of the assembly. I pretty much always take it into SpaceClaim and use this cross-section feature that I just showed you and that we're going to use again. Because we might want to just take a slice through this geometry through here and see if there's any gaps or intersections of parts. Since we're going to perform an analysis on it, we might want to take care of that. So let's create some construction geometry first. You don't need to do this, but just showing you a couple things. If you click on a surface that's cylindrical, you can put an axis through it. If you have that axis selected, you can create a plane from that. That plane goes through that axis. If you didn't like the orientation of this plane, again, this is the move tool is highlighted. You can just click on, say, one of the axes for how you want to move that plane. Hit the space bar to toggle that so you can type in a number if you want to move that plane in a different direction. I was happy with how it was before. So we have this plane, and then we'll go into the cross-section mode and orient the view normal to this. And now we can look in this assembly and see if everything is lined up properly for an analysis. And we see if we zoom into this bolted flange region, there's a bunch of gaps between these components, which if this was bolted up, those should probably all be mated together. So we can easily find those things. Also, there's interference of a part over here. So we might want to take care of basically the position of these assemblies. So we could do that with the move tool. If we just want to move this one body over to close that gap, we could do that. But in cross-section mode, you're selecting on edges, which really represent faces. And I really want to grab the body. I want to move the entire body over. So if I just select an edge with some options on the right click, you can locate this in the tree. So there's a body that corresponds to this. So if I select the body, click Move, and zoom out a little bit, that move centers at the origin of mass for this geometry. So if I drag this over and put it on that face, actually let me do it this way, set the origin off of the midplane of this line on that face so we can see this easier. Now we're moving this body from this location. Click the direction of the move. So I'm going to click this arrow with the left mouse, and then we're going to say up to this edge right here. So now it moved that entire body over. So that might be a lot of clicks and things to close that gap. A better feature to do this is actually using some of the assembly conditions right here. So we could do something, say, like tangent, or we could grab the face on this body and make a tangent to this face, and it will slide everything over. That's certainly a quicker way to do it. If we look down at this centerpiece of this valve in green, we see that there's a bunch of gaps. So this is kind of floating in space. We need to put contact in here if this was a structural problem, or maybe we try to close these gaps. These parts are line on line. we could do something like that very easily with the pull again, which is, just grab the edge right here, and we can pull this up to the diameter of this part right here. Now, notice when I did that, we grabbed the edge on this body, and then it was touching these other two bodies. So once this pull is then touching this inside cylinder, it merged everything together. That's probably not what we want to happen. So if I undo that, then with the pull, there's some additional options over here where we can choose no merge. So then if we pull this surface up to this one and not merge, then it doesn't group those together. And that's really why that got merged together is based on how these parts are assembled in the structure tree. So all of these bodies that are right in here are grouped into one component right here. So it might make a little bit more sense to have each of these individual bodies be separate components. So if we do that, if I select all these bodies in the tree, I can right-click and move each of them to a new component. So now we've laid out the structure tree a little bit different where each body is now in a separate component. So if we did a pull again, where we say pull this edge up to this one, now without having to use the no merge, it automatically does not merge the bodies together. And that's just because of how things are laid out in the structure tree. So there's some importance of understanding, how to lay out and work with bodies in the tree. Another advantage of doing this is that if we wanted to go in here now and, let's say, close the gap between these two parts using the assembly condition, if I do tangent of this face to this face, it slides that together. If I grab this face and then this face, now it moves all of these parts together. Same thing with this part to this part. These are all now getting stuck together. So, and also notice I used the tangent previously to put these together. Well, these didn't stay together, and that's because that was prior to changing the structure tree. So all that this means is that if, let's say I grab this body, and then we use the move to move it, these are all linked together. So that's just going to save us a little bit of time if we're trying to assemble a bunch of things together to kind of have them stay together. And then if I want to remove this intersection over here, we could do that with the Combine tool. There's also there's a Prepare tab, which it searches for any interferences in the assembly, and then you can click them and remove that. But if I just stick with the tools that I've been showing you so far, Combine, click the body that we want to slice with, another click on the body we're going to slice with, and then the intersection, we remove that. So that takes care of that interference. Another thing we might want to do is take care of, the gaps that are in this bolted connection. If we want to do something like that, if we go back into the 3D modeling mode for a second, there's 4 bolts, but let's just say that, you could say that there's hundreds of bolts that you want to all edit at the same time. So doing something like that, let's say we grab this one body here, just click on a surface, right-click, and I can go down to Component and open this component out of the assembly. So down at the bottom, all that it did is it opened up a new tab with this part. So if I wanted to, I could do something like remove this hole, and I could do that with this fill operation. So this will fill the hole, kind of like face delete in Design Modeler. So then if we go back into this assembly, let's see, for this part, so let me go back in the cross-section mode on that cross-section on that plane. We see that this is now filled in. We could use Combine to then put the hole back into the right size of the bolt. So click this body to cut with this bolt, and then third, click to remove the intersection. And then if we go back to the bottom down here with this part, you see that that hole was put back in. Now, this hole, we might want to do that with all of these holes. If I click on this one hole over here, I don't want to have to go through and select maybe 50 bolt holes. There's a selection feature in SpaceClaim that allows you to kind of smart select. So if you click on this surface, it'll find all the holes that are equal to that same radius. So then we can search the model based on these different things. And then we could use pull up to, and then just click the inside diameter in here, and then it will pull all these holes up to that same radius. And we can just double check that that worked. If I click this surface again with the power selection here, just grab all the equal radius cylinders, and now those are all the same. So that means back in our assembly, the other hole that was down here, got updated. So you can do things like that. Like I said, SpaceClaim cross-section mode is very useful for interrogating and aligning assemblies, making sure everything is ready for your analysis. Let's just take our second and last poll before I show you one more thing with SpaceClaim. So Christina, if you can load that up. Okay, so the next thing is, after seeing a little bit about SpaceClaim, if you haven't used it before, do you maybe plan on trying it out in the future? So if you go ahead and answer this, anyone that has a mechanical license and are using version 17 of ANSYS now have SpaceClaim. So that is an added capability that you now have that maybe you didn't have prior to version 17. And SpaceClaim gets installed with Workbench, so you would have that as an option to edit the geometry already. So let's see the results of this. You plan on using it? Looks like we got 25% yes, 25% maybe, some no. So that's good. I mean, maybe there's a little bit of interest after seeing some of this. Like I said, it's certainly available to you with the version 17 mechanical licensing. So it's always good to poke around with tools that you have access to if you care to use it. So then the last thing I want to show you is defeaturing geometry. And I use SpaceClaim, again, all the time. I find it very quick and easy. It has a lot of great tools beyond what I've been showing you so far. So this is basically, we can make this a quarter symmetric model here. So I can do that quick. I can slice this up. If I just select the bottom surface down here, it puts a little origin down there. That's actually the move center. I can click this option to create an origin. If I click on the origin and then click the plane button, it'll create the 3 orthogonal planes off of that. So we can use that to slice this into a quarter symmetry model. We can do that again with the combine tool, where we click on the body. We're going to combine it, in this case, by slicing with this plane and then removing the slice body with another click. Split body does actually the same exact thing for this example if we slice with a plane, but it gives you additional options where you can select on faces and then slice with those faces, virtual faces. So get rid of that. Now we're left with this geometry. So let's say we wanted to make this more topologically simple. We could double-click on one of these blends. It grabs the round chain, and we could use the fill operation to fill that in. And double-click over here, it gets all those blends and fill those in. So we can go through and defeature this. Now if I double-click this and want to remove all those rounds with the fill, you see it starts to hang up here. I'm going to hit the escape key on the keyboard, which is actually quite nice. You don't have to wait for that operation to maybe eventually fail, after if you did something rather complicated with hundreds of surfaces and it just was getting hung up. You can always hit escape to get out of it, cancel it. I find that really useful. So this is a round that can't be removed with the fill tool. Fill, it removes holes. It basically tries to rebuild the surrounding topology by deleting the entities you have highlighted. So we're not stuck. There is actually a feature specific for this in SpaceClaim, which is remove rounds. And if we zoom in here so you can see this a little bit better, if you just, with the mouse highlighted over this round, if I just move it over to this edge of the round, you see that there's some purple lines that show up, like going across the round, and then they move with the cursor. So when I left-click, it deletes out that round and slices it between those two purple edges. So this outside corner gets a sharp edge. Same thing down here. You get a sharp inside corner. So we just kind of chop away that blend, and then I'll just box select these rounds and then remove those. So difficult rounds, you can just kind of chop away at them using this technique, and then slowly delete them, and then you get something that's more simple here. If I go back to, I could just remove this with the round that I'm already in, but if I go into selecting these edges and use fill, then it's more simple and we can fill it in. So that's a way to, defeature things that, especially in this region, you could get this, I've done it actually already, but you could get all these rounds to be removed by hacking away at them. And then I could also double-click this edge right here, and if we wanted to put them back in, let's say, you can use the pull tool, and then just, with the left mouse, just drag it to the value we want, or hit the space bar, and then type in a value that we want that to be. And then anything that you type in, like a move, pull, that has a number like that, there's a little P that will show up next to it. If you click that, that's now a parameter, and that parameter gets stored under the Groups tab. And if you're not in any tools at this point, that gets saved, and we can edit it anytime. And these parameters also go into Workbench. So you could update these parameter values on the Workbench project page and then have them get backfed into SpaceClaim and perform the update that way. So it is can be parametrically tied that way to Workbench.